Hi, welcome. We're doing 12.3, which is page 62. The first two problems are review, so pause and do them on your own. Find the area of the smaller sector. So the smaller sector right here is like that piece of pie. And remember, if we want to find the area of a piece of it, we had proportions we were setting up. So I set up a proportion. I put the area as the piece. I put the part of the triangle on top, and I put the whole triangle on bottom. So I always put the area that I'm looking for, that little piece goes over here. The degrees go over here. Remember, the part degree goes up top, so I'm going to put 60 degrees up top. And the entire degree of a circle is going to be 360. Now, the area of this part is what I'm looking for. Can I figure out the area of the entire circle? So the area of the entire circle down here. Find the area. So area is going to be pi r squared. Remember, pi r squared. Well, what is my r at this point? My r is 9. So then I'm set up. Now you just have to solve this. We're going to cross multiply. I'm going to simplify first. 60, the zeros cancel, so I get 1, 6. I'm going to multiply 81 pi over here. Divide by 6. So I don't really know that it divides evenly. It does divide by 3. I can divide by 3 here, and I get 27 pi. 6 divided by 3 is going to be 2. 27 pi over 2 is my area, and my units here are going to be centimeters squared. So there we go. You could use a calculator to find a decimal answer, but this would be something that you'd want to do as an exact answer. If I asked it on ALEKS or on Canvas, 27, remember to use your pi symbol in your calculator, 27 pi, and then go ahead and divide it by 2. This would be approximately 42.4. It is not likely that I would ask that. I would ask it in this format more often. Okay, the next one is an extension of it. Now we want to find the length of arc AB. Well, arc AB is this right here. And if I want length, that means I want part of the circumference. So I'm going to set up the exact same problem, basically. We still have 60 over 360, which I already know is 1 over 6. So I'm just going to write 1 over 6 because it's the same. Now over here, I want the length of the entire, the part of it on top, the entire length or circumference down below, which is 2 pi r. So 2 pi, my radius is 9. So here I can cross multiply. I'm going to multiply over here. I'm going to get 9 times 2, I'm going to get 18 pi. And I can simplify 6 goes into 18 3 times. So my length here is going to be 3 pi. My units are centimeters. There we go. So it's nice that the setup's exactly the same. You just have to decide if you're talking about length, circumference, or you're talking about area. Now down here, I want to know the square root of 147. Not much to plug in your calculator. Is there a factor that's a perfect square? We have a factor of 49 times 3. Square root of 49 here is going to be 7. Square root of 3. This is our best answer. Now the area of a triangle. Now, area of a triangle is 1/2. Base times height. I have a base. And even though the height's outside the triangle, it's still the height of the triangle. So area of the triangle is equal to 1/2. My base times my height. My base is 6, my height is 5, half of 6 is 3, times 5, I end up with 15 meters squared. These are just some review problems. Hopefully you pause and come back and do those on your own. Okay, we're going to do another review problem of the parabola. I'm going to set up my highlighting for you because I like that. Remember, this is based on that, my vertex, my y-intercept, x is 0, my axis is symmetry, x equals, so your vertex here is going to be in the middle, and it's going to be your axis of symmetry. I'm going to look for my y-coordinate here, and I'm also looking for my y-intercept. So, pause, do this one on your own. Remember, this is a plus or minus. This is negative b over 2a. And you can solve this from here. So my a right here is positive 2. It is going to open up. Negative b over 2a is going to be negative 4 over 2, 2. Remember, positive 4 over 4 is going to be a 1. So my pink right here is a 1. This is a 1. This is a 1. Those are all the same. Vertex, axis of symmetry, and then it goes in the middle. I can also come over here and do that one right away. And then my axis of symmetry is going to be right here. I can draw it. Axis of symmetry right there. So now I'm going to do the vertex here, plugging it in. If I plug one in, this is the work for my green if you want to follow along. So 1 squared times 3 at 2 minus 4 minus 6, 2 minus 10 is going to be negative 8. I go to 1, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. I know I'm opening up, and we'll talk about this in a minute. I want to go left of 1 and I want to go right of 1. Let's say I go 1 over and I get 0. 0 is going to work. 0 is going to be pretty decent. I didn't do it on my last notes that I did, but this is going to be 0. This is going to have the same effect because it's the same length away. So if I go 1 to the left, I'm going to be 0. 1 to the right, I'm going to be at 2. If I plug in 0, 0 minus 6, I don't even have to plug 2 in. But 2 squared is 4 times 2 is 8, minus 8 minus 6, I'm still going to get negative 6. 1, 2, 3, 4, 5, 6 right here. Now I went over 1 up 2. It's going to have to do with that 2 if you remember. I can pick negative 1. If I pick negative 1, I'm going to pick 3 over here. Doing this work here. Negative 1. There's 1 times 2 at 2, plus 4 minus 6. This is going to be 0. Negative 1, 0, which means I'm going to get 3, 0. So it's not really, I want maybe one more, so I might go one more. Let's say we pick a negative 2. If I pick negative 2, I'm going to pick 4. Negative 2 squared is going to be 4 times 3 at 8. Negative times negative is positive 8 is 16 minus 6. I end up with 10 here, which means 4 is also going to be a 10. So if I go negative 2, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, all the way to the top. 1, 2, 3, 1, 2, 3. There we go, that's my parabola. Now notice that I went over 1 up 2, over 1 up 1, 2, 3, 4, 5, 6. 2, 6, 10. So pay attention to those increments as you go as well, and draw your parabolas if you can. Nice skinny parabola. There you go. Okay, so our new notes for today, we're going to talk about surface area of pyramids and cones. So I think, what did you do yesterday? Surface area of right prisms and cylinders. So this is going to be similar to that, but a little bit different because they're slanted. So a regular pyramid, this is a regular pyramid because all the faces are the same. Lateral area is equal to 1/2 perimeter times your slant height. This L right here, this cursive L, is your slant height. Okay, it's this length right here. Now, 1/2 the perimeter of the base right here. The perimeter is this length down here. 1/2 the perimeter, and then this B, capital B, stands for area of the base. So the area of the base goes there. So you kind of have to work these out. Here's a pyramid. Lateral faces are all the edges. This one is not regular, it slants a little bit. A non-regular pyramid is not going to have a slant height because they'll be different on every face. Okay, going to the second page. A regular hexagon right here. Hold on one second. It's off showing you that if you had this hexagonal pyramid, a hexagon on the bottom and all the sides are triangles, so it's a pyramid, you could open it up. It's kind of called the net. If you could open it up and see all the sides independently, you could find the area of each individual side and the base and then add them all together is the idea if you needed to open it up and have a net. There are specific formulas that we can use, and you kind of have to remember the setup of the letters. S is the area of the base. S is the surface area of the shape, which is the area of the base plus the area of each lateral face. In this case, there would be 6. So the area of the base, and then all the faces are triangles, so 1/2 base times the height, which is the slant height here. So that's where you get the L. Surface area is area of the base plus 1/2. Well, because the base really has 6 of the same thing, we're going to do 6 times each base to get all the bases times the slant height. So that's why we rewrite and add basically the perimeter of that shape, so you get all of them in one. You could do them all separately, one at a time, or you could do them all in one by multiplying the perimeter times that base. So the actual area is going to be area of the base plus 1/2 perimeter times the slant height. So if you want to use the formula shortcut, you can, or again, you could do the net and find each individual one by itself. So down here, I'm going to do the formula. I do these letters in order each time, and it helps me be consistent and make sure I don't miss anything. So I write the letters down even if they're not there. The slant height, do I see the slant height? Well, yeah, the slant height here is 9. So I get 9. All of these have units, so it's 9 feet. The perimeter. Well, the perimeter of the base here, it's a regular pyramid. 1, 2, 3, 4, 5, 6. Each of them is 4. So the perimeter is going to be 4 times 6, which is going to equal 24. Perimeter is feet. Okay, so my lateral area is going to be the area of all those faces. Well, they're all triangles, so it's 1/2 base times height. Well, in this case, the base, though, of all of them is the perimeter, 1/2 perimeter times the height in this case, which is our slant height. So I already have those things up above. I'm going to have 1/2 times the perimeter here times the slant height. 1/2, the perimeter is 24. Slant height is 9. Half of that is 12. 12 times 9, I get 108. Lateral area, it's area, so it's going to be feet squared. Okay, so now the area of the base, I've got a polygon here. So remember, I don't really have the formula for the area of a hexagon, but I do know that the area of the polygon is 1/2 apothem perimeter. So 1/2 apothem perimeter. And well, I already figured out the perimeter, so that's nice. I know the perimeter right here is 12. No, sorry, 24. Thank you. And the apothem, well, if this is 4 and this is a hexagon, every single time it works out the same way. So I am looking for this piece, this triangle right in here. So remember that when you have this triangle, the whole triangle is going to be a 60, 60, 60. I want half of it, so that half triangle right here is going to be, I'll do it in orange so it matches, a 30, 60, 90. And in this half triangle, well, remember the 30, 60, 90, your general form, your shorter leg is x, your hypotenuse is 2x, your longer leg is x root 3. Well, in this case, if the whole thing is 4, this piece right here is going to be a 2. So if this is 2, this is 4, this is 2 root 3. This right here is the apothem right here. So that's my apothem that I'm looking for. So I'm going to go ahead and put in 2 root 3 right over here. What size 1/2 times 2, that'll just divide out. So I end up with 24 root 3. This is area of the base, so area of the base, make sure you have your units squared. So I'll have feet squared. Okay, so now the surface area, I have the area of the base by itself, I have the lateral area. Surface area is going to be my lateral area plus, now this time I don't have 2 bases. In the last set of notes you had 2 bases. This time I only have 1, so I just have to add 1 base over here. My lateral area is 108. My surface area is 24 root 3. That's all feet squared. I cannot combine those because they're not like terms, so I'm going to leave it feet squared. And there we go. Note, we might use the lateral edge or height to find the slant height first. So right here, if I don't know what the slant height is, and I've been using pink for it, notice that I have this triangle here. Trying to look for different. I don't like that one. I have this right triangle. I might need to use these things right here, or the edge to use Pythagorean theorem and find it, or the edges or something to find it. So if this is 12, if this whole length is 10, what is half of that? This right here is going to be 5. So I have a 5, 12. Hopefully we kind of know this or start to recognize our Pythagorean triples. But if this is 5, 12, 5 squared is 25, plus 12 squared is 144. I get 169. The square root of that is going to be 13. This is a 5, 12, 13 triangle. It's one of our Pythagorean triples. Go ahead and fill in all your letters and answer this on your own and then come back and check. Okay, so here's all the information. A wooden jewelry box. My slant height here is 13 centimeters. My perimeter is 10, 20, 30, 40 centimeters. My lateral area, remember the lateral area is 1/2 the perimeter times the slant height. So again, 1/2 my perimeter is 40. My slant height is 13. Half of 40 is going to be 20 times 13. I get 260 centimeters squared. Now the area of the actual base here, it's a rectangle. It's going to be 10 times 10. I get 100 centimeters squared. And then my surface area here is my lateral area plus 1 base because it's a prism. It's one of my triangular prisms. So I have lateral area is 260 plus my base area is 100. There's no roots here. I can combine this one this time. So now that I can combine like terms, I end up with 360 centimeters squared. You would get points for each one of those steps. If I write this in a test, I would ask you to tell me each one of these as you go. Going on to the last page. Now this is similar, only now it's not a pyramid, now it's a cone. So if we have a cone, what is going to change? Not much, actually. So the lateral area is still going to be half of the circumference, which the circumference is just really another word for perimeter, only when it's a circle, right? So here's our perimeter of a circle. And then our L is our slant height still, and we're still going to take half of it. That is one thing that happens with the area, surface area. When there is one base, you have to remember that you're going to have half. This did not happen with the rectangular prisms the day before. The rectangular prisms, you did not have the halves. You have the halves when you have one base. Okay, so circumference right here, which is again the perimeter of a circle, 2 pi r. Lateral area is going to be 1/2. So if you watch this, lateral area is 1/2 2 pi r times the slant height. So if this is essentially 1/2 times 2 pi r, that's going to cancel. So your lateral area here actually is pi r L. I don't like to remember that one. I don't use that because I want to remember that it's half because it's one base. So I do this every time. You can do, this is the same thing because that 2 and 1/2 are going to cancel. It's up to you what you want to remember and work with. I use this because it makes sense in my head when I'm thinking it through. So again, surface area here, lateral area plus 1 base. Base is circle, pi r squared. So the surface area is pi r times the slant height, this over here. Again, I don't use that. I would do surface area equals 1/2 circumference slant height plus area of the base, which is pi r squared. So I don't really like, this one's not really my favorite, but same thing. So I'm going to come down here, slant height, pause, do this one on your own. Slant height is going to be 8 inches. Circumference is going to be 2 pi, the radius here is 5. So my answer here is 10 pi inches. Now be really, really careful. Don't forget the pi. It's easy to forget that. You don't want to multiply by pi. Just leave it in your answer. That's what you want it to look like. Again, the lateral area is 1/2 the circumference times the slant height. So I have 1/2. Circumference is 10 pi. Slant height is 8. Half of that 8 is 4 times 10. I get 40 pi. Don't forget the slant height. Or did I do a... Yeah, 40 pi. Don't forget the pi, not the slant height. Don't forget the pi. Lateral area is going to be inches squared. Okay, now the area of the base. Remember, area of the base is going to be 1/2. No, sorry, circle. Area of base, pi r squared, it's late. Pi r squared. Area of a circle right here, radius is 5. I end up with 25 pi inches squared. So my surface area, again, remember, is my lateral area plus, when I have a cone, I have 1 base, not 2. So I get 40 pi plus 25 pi. It's nice when they are like terms because we can combine them, and I end up with 65 pi inches squared. There we go. Find the slant height of a right cone that has a radius of 12 inches and a surface area of 324 pi. Okay, I would probably start backwards. I'm still going to write my letters down, and I'm going to work backwards. Slant height, circumference, lateral area, area of the base, surface area. I know that my surface area is 324 pi, which is the area of the base plus lateral area. Lateral area plus area of the base. Find the slant height of a right cone that has a radius of 12. So circumference is 2 pi r is my 12. That's going to be 24 pi, I know that. My lateral area is going to be, again, 1/2 circumference slant height. So 1/2 circumference is 24 pi times the slant height is what I'm looking for. Find the slant height. So I kind of talked myself through the problem. I'm writing everything down that I know. I'm looking for the slant height. I need the slant height here. Radius of 12, area of the base. Find the slant height of a right cone that has a radius of 12. So area of the base is going to be pi r squared. Radius is 12. That's going to be 144 pi. So working backwards, what do I know? Well, that area of the base right here is 144 pi. Can I now work a little bit? I need to figure out this lateral area. So if I'm going to subtract 144, 324 pi, minus 144 pi, I get 0. I get 180. So I know that my lateral area here is 180 pi. So what I'm going to do from here is, if I know this is 180 pi and this is what I'm looking for, half of 24 is actually, I get 12 pi times whatever the slant height is equal to 180 pi. So I'm going to divide both sides here by 12 pi and get my slant height of 12 goes into 180. How many times here? 15. So I just worked backwards and I found that my slant height here is 15 inches. So starting from the beginning, fill in what you know, play around with it, and kind of work like that. Good luck. This one is really ugly. I'm going to just show you my work for this, and then I'll talk it out with you. Find the surface area of a 12-inch tall cone with a 9-inch radius that has had a 6-inch diameter hole drilled through the center. You're not going to see this a lot, especially right now. So don't freak out about this problem, but those of you who want to kind of pay attention to it, it doesn't hurt. Okay, so here is my work for this problem. You're drilling a hole through all the way. The slant height is 12 inches tall with a 9-inch radius. Has had a 6-inch diameter, so this is 3 inches here because it's 6 inches all the way. So the slant height, if this is 9 and this is 12, 9, 12, 3, 4, 5, 9, 12, 15. This is a Pythagorean triple, this pink triangle here. So 9, 12, use Pythagorean theorem. Did I use it anywhere? I did this as my Pythagorean theorem. But I know this is 9 and 12, 3, 4, 15, 3, 4, 5, 9, 12, 15 is a Pythagorean triple. So we know the slant height. 2 pi 9 18 pi is the area, or the circumference down here. Lateral area, 1/2 slant height. 18 pi is the circumference. Area of the base, 81 pi. Surface area right here, 135 pi plus 81 pi. Now, what we have to think of is we have the surface area all on the outside here, but we need to take away this area because it's no longer going to be there. And we need to take away this area, this cone, and we need to add in the cylinder in here because now it's going to be open to the elements and it's going to be touching outside. So we're still doing a lot of the same things here. We get 135 plus 81, I get 216 pi for the surface area, but I have to take away this triangle, or this circle, sorry. I don't know where I did the work for that. 2 area of the base, 3 squared, 9 pi right here. So this is 9 pi, that circle. The area of this up here is this cone. 3, 4, 5. Find the area of that cone. That's going to be our 15 pi. The lateral area is 1/2 slant height times the, lateral area 1/2. What was the cone? 1/2 circumference times the slant height. So 1/2 circumference times the slant height. We get 15 pi here. So the 15 pi for the green part up here, the 9 pi for this piece down here is 24 pi altogether. I need to subtract that, so I have it color-coded. Now I do want to add in this red edge of the cylinder. So that's going to be the height is 8, circumference is 6 pi, lateral area is 48 pi. Now, when you're adding the surface area of the cylinder, you're not adding the bases this time because the bases are open. So you just need that lateral area, which is height times circumference, 48 pi. So I'm going to add that in and get 240 pi, inches squared. Again, this one is above and beyond, but you can fill it in and go with it from there. If you have questions, come back. I know I rambled a lot of that one. Anyway, have a fabulous day. Sorry it was so long. I will see you next time.